Miscellaneous theorems. Milliman's theorem, Tellegen's theorem, reciprocity theorem, compensation theorem, substitution theorem. In case of Milliman's theorem, set of voltage sources are connected in parallel along with their internal impedances across the selected impedance or load impedance. So this total network can be simplified as one single voltage source along with resistance, that is equals to Thevenin's circuit. Similarly, in the same Milliman's theorem, set of current sources along with internal impedances are connected across this load impedance, so that this set of current sources can be replaced by single current source along with its internal impedance in parallel with it. So for that, these are the basic formulas. So final voltage source V equals to V1 G1, V2 G2, V3 G3, and the polarity is as per the connections of voltage sources in the circuit. So here V2 is connected with reverse polarity, so that V2 G2 is having negative sign. In the circuit, resistance values are given, but in the formula we have to take G values. G means conductance. G1 plus G2 plus G3. So final Thevenin's voltage equivalent equals to sum of Vg by sum of G. The second case, where the current sources are given, the final current source value equals to I1 R1, I2 R2, I3 R3. This is sum of resistance R1, R2, R3. Whereas sign has to be as per the current source direction. Whereas I2 direction is downwards, so this is negative sign. So here sum of IR divided by sum of R will give us current source value. This kind of circuits can also be simplified by using nodal analysis. So basically, the goal of all the theorems is, in any given network, one particular branch is selected and the total network can be simplified across these two terminals of the selected branch, so that current through that branch, voltage across that branch, and power consumed by that branch can be easily calculated. Tellegen theorem. This theorem mainly deals with law of conservation of power. Algebraic sum of powers in the circuit must be equal to 0. That means power delivered by the active sources and power absorbed by the passive elements has to be equal to 0. Power delivered must be equal to power absorbed. So delivering power we usually take with plus sign, absorbing power usually take with minus sign. Reciprocity theorem. There are few conditions for this reciprocity theorem. There must be only one independent source in the circuit, and this must be completely resistive network. So we have to ignore the initial conditions of the sources. So here R4 is selected as load branch and current is calculated in this branch, that is I. So this is the source, this is the load resistance RL, and this is the current I. As per reciprocity theorem, if we interchange the positions of load resistance and source voltage, that means the source voltage is connected here, the load resistance is connected here, and the total network is kept as it is without any modifications, then the same current I will flow again in this load resistance RL, even though positions are interchanged. So the location of source and resistance, these both are interchanged. The same current will flow. When resistance was here, same current I will flow. When resistance is here, the same current I will flow. That is reciprocity theorem. Here the voltage is 10 volt. The current is I here. The voltage is 20 volt and the polarity is changed. Then here the current will be 2 ampere with the reverse polarity. So simply we have to multiply with minus 2. Compensation theorem means for small change in load resistance, there will be change in current. So I equals to V by R. So in the circuit, this is the current and the total circuit current is V by total resistance, RTH, RL and change in RL. The sign is as per the current flow direction. Whereas substitution method, one particular branch can be modified in many ways. So this is one particular branch, whereas 3 ampere current is growing, resistance is 2.5 and voltage is 7.5. This branch can be represented as directly 15 voltage source and 3 ampere current. This can also be represented as 3 ampere current source with 15 volt across these terminals. So basically, one particular given branch can be represented in many ways. So basically, this is substitution method. So we have completed all the theorems. The purpose of all the theorems is, in a given network, we can select any one particular branch. Across this branch, all the network can be simplified so that we can find current through this branch, voltage across this branch, and power consumed by this branch.